One of the most basic and important kinds of functions is a linear function. So linear functions, these are functions that tell us about lines, and you can actually see the word line hidden in the word linear here. So linear related to lines. So let's start with the representing linear functions by formulas. If we have a linear function, its formula is going to look like this. F of x equals some constant m times our input variable x, and then we could have another constant added on. So, and this mx plus b is going to look familiar. This is exactly the right-hand side of a slope-intercept form of the equation of a line. So a specific example would be something like f of x equals, let's go with 2x minus 3. So here the slope of the line that we end up graphing will be 2, and the y-intercept will be negative 3. But this is a linear function because x appears with exponent 1. There's no higher powers. It's just a constant times x plus another constant. Any linear function can be given a formula like this. All right. And if, as usual, if we want to evaluate this, we're just plugging in whatever input number we're considering wherever we see an x. So the 2 will stay the same. If we're doing f of 7, the x will become a 7, and the 3 will stay the same. So this becomes 14 minus 3, or 11. So input 7 gives us an output of 11. All right. So that's what formulas of linear functions look like. Let's talk about tables for linear functions. So let's just evaluate a few different inputs here. Let's go negative 1, 0, 1, 2, and see if we notice anything. If we input negative 1, so then let's keep this same formula. So 2x minus 3. So if we plug in 1 for x, or negative 1 for x, excuse me, we get 2 times negative 1 minus 3. And we end up with negative 2 minus 3, that's going to be negative 5. If we input 0, we get 2 times 0 minus 3. 2 times 0 is 0, minus 3 is negative 5. If we input 1, 2 times 1 minus 3. 2 minus 3 is negative 1. If we input 2, we end up with 2 times 2 minus 3. So 4 minus 3 is positive 1. So let's take a step back and look at what's going on in this table here. Every time we increase x by 1, the y value goes up by 2. Negative 1 to 0, y values go from negative 5 up to negative 3. If we increase the x values by 1 more, negative 3 up to negative 1, that's another plus 2. 1 to 2 in the x side brings us from negative 1 to positive 1. That's another jump of 2. So this is a plus 2 pattern. And so if we remember what we were saying about sequences a while ago, linear functions are plus patterns. And you'll see those plus patterns in the tables. Now let's talk about graphs of linear functions. So we said we're going to see a line here when we graph this. So let's plot these points and see what we get. So negative 1, comma negative 5. So negative 1, 2, 3, 4, 5. So negative 1, negative 5 would put us about here. 0, comma negative 3. Put us there. 1, comma negative 1. And 2, comma positive 1, put us about there. So you see this sort of, it looks pretty close to all those points being on the same line. And yeah, that's not perfect, but pretty close as far as hand drawings go. And so this is the graph y equals f of x. If you were to add more rows to your tables, they would all be on this line. So that's what the graph of a linear function looks like.